Welcome to qnawire.
Hello and welcome to this video's illusion of numerate. So here we are given a small object with mass m and charge q and initial speed v0 that is equal to 5 times of 10 to the power of 3 meters per second is projected into a uniform electric field between two parallel metal plates of length 26 centimeters, right? So length of each plate is 26 centimeters, kind of like this. The electric field between the plates is directed downwards and is having a magnitude E, which is equal to 800 Newton per Coulomb, right? Kind of like this. This is V naught, and the electric fields are directed down, right? This is 26 centimeters, and assume that the field is zero outside the region between the plates. The separation between the plates is large enough for this object to pass between the plates without hitting the lower plate. After passing through the field region, the object is deflected downwards by a vertical distance d, which is 1.25 centimeters, right? So this is the straight, and here you have got deflected by a distance of uh, 1.25 centimeters, right? And the collecting plate is 56 centimeters from the edge of the parallel plate, right? So this distance is 56 centimeters. Now you have to calculate the object's charge to mass ratio, right? Now what you can do is you can first calculate the deflection in the electric field, right? So here you have got, let's say d1, that is equal to, using the expression ut plus half at square, right? So this is the expression of the deflection, and let's say this is t1 I'm taking, right? The first initial time. Now this t1 will be equal to L, the length of this plate, over the speed, right? U, or v naught. And also you have got the acceleration to be equal to the net force over the mass, right? Now the net force is, you know that it's charge times the electric field over the mass, right? So this is a value of acceleration. So using these two conditions you can plug in and find the value d1, right? So d1, it's equal to uh, mm, this u will be uy rather, which is 0 because there is no initial vertically downward velocity, right? Plus half the acceleration is qe over the mass, and t1 square is L by v naught whole squared, right? And this will be around mm, qe L square by 2m v naught squared, right? So this is d1 you have got. Now next you have to consider, calculate the time it will take outside the magnetic field, right? So this is t2, which is equal to outside length, which is 56 centimeters, is L, let's say capital L I take, right? So this L by the velocity v naught itself, right? Because this is the horizontal velocity with which it will cover the entire distance, right? And you have to consider, calculate the vertical motion also, right? So to calculate the vertical motion, uh, that will be, you have to find out the vertical velocity v dash, which is equal to u plus at, right? Uy plus at, and this will be equal to, this is t1, right? The initial time, and here you will be having qe by m times of L by v naught, right, is the time. So now this d, which is the deflection in the downward direction, will be given by this v dash times the time t, right? And this is equal to, or let's say this is d2, which is equal to qe L times of capital L over m v naught times v naught square, right? right? So this is what you have as d2. Now the overall total deflection d will be equal to d1 plus d2 now, right? And this is given by, this is equal to half qe by m times of L square by V naught squared, right? Plus here you will be having QE by M times of small l capital L over V square, right? V naught squared. So this is what you have as the overall deflection, right? Now you can plug in all the values now. The overall deflection is 1.25 centimeters, which is 10 to the power of minus 2. And here you can take QE Q by M to be common, right? To be common, and here you will be having the electric field is 800 by 2 times the initial length is 26 centimeters, right? Which is 0.26 meters squared by V naught is 5 times of, okay, so this is also squared, 5 times of 10 to the power of 3 whole squared, right? Plus, sorry, you can take this entire thing also common, I think, E, or let's say let's do it separately, and here you will be having q by n again common, so 800 is the value of electric field times the product of the lengths, which is 0.26 times of this is 0.56, right, over 5 times of 10 to the power of 3 whole squared, right, like this. So let's see how much we have for q by m, the ratio. This is around 2178, right, is the value of q by m. I hope this is clear to you, and have a very good rest of the day. Thank you.